Alright, okay, beam design in tabs. The first thing is you need to know about load combinations, which could be correctly read away from here from class 36.4.1. It's 1.5 dead load, 1.5 dead load and live load, dead load and wind load, dead load and wind load, dead load, live load and wind load. That's all. This is earthquake load, which is comes under seismic part. Alright, this is our problem. The length of the beam is 6 meter, then the height is 600 meter, the section size is 603. Alright, the first thing that we're gonna get into ETABS, and we're gonna just try to look at the FCK is 15 megapascal. Okay, the load is 37.77 kilonewton per meter. This is the shear modulus, this is the elastic modulus. Get into new model. I'm gonna pick this option here, and I say that the length is 6 meter given in the problem. We don't need this grid, but the number 2 will be better. We don't need this thing, but just 2 stories. Don't care these numbers, okay? Alright, okay, the first thing what we need to define is the concrete and HYSD, obviously. Come on, just get into the state, country, concrete. The grade is M15 based on this problem. Well, I think it's right here, M15, and the HYSD is 4 and 5. Alright, okay, so now the settings should be changed. Okay, just assume that this value is 8068.72. Just coming to slide. What's this a slide here? 8067, approximately that's correct. Just hit OK, then just get into here and make sure that this is 15 megapascal. And also we need to want the rebar. Picking up here, rebar grade is 415. Rest of the things I'll leave it as it is. Just as 4 and 5, it's okay. Okay, now we need to define a section property of a community frame section and add new property here, and adding the property get into the rectangular section, and this one is a beam. Get into the compressive strength is 15. Now the section size is 600, and I think the depth is 300, I think. Okay, rebar modify, it's and the cover is 37.5, I think. I'm not sure. It's right here, just 37.5 is the cover. Right here also 37.5 is the cover. That's all, leave it as it is. Alright, okay, now we got the beam here. Now let's draw that beam. Just click in here. We got a beam right here. Now what I'm gonna do here is I'm gonna make a combination of 1.1 into ultimate load. So in the ultimate load, I'm gonna giving this value of the load. Okay, I'm not gonna care self weight, or either you can come into define and this load patterns. I'm gonna hold on. What I'm gonna be doing here is I'm not going to add any new load. I'm gonna be disabling the self weight multiplying factor to 0. And I'm gonna be concentrating only on dead load. I don't need a light load here, and I'm gonna make a combination on dead load. Okay, in here I'm gonna select this beam. What's this? I'm gonna be selecting this beam, and I'm be applying a distributed load of the values. I think 37.778. Right on the gravity direction. Okay, then let it stay here, and I'm gonna be creating a combination on this is dead combination of 1 times dead load. Okay, let it stay here. It's not necessary at all. Watching the bending moment diagram of this crap, sorry, it's right away here. No, this only this combination is not enough. Okay, not needed. The combination is not needed. Let me see, the value comes to be 170.01. Okay, let it stay there. Now just coming into a concrete frame design, you know all these things, right? Well, it's not possible to proceed without. There's a problem there. We need to have at least a combination to proceed. So gonna be coming here. Alright, okay, let's stay there. Analysis. This is crazy. What's wrong? What went wrong here? Mainly the biggest mistake is I didn't pick this up correctly. Sorry. As the self-weight is not included, they're not gonna be showing anything. Okay, now let's get into the combination, picking up the combination, and only that combination will be considered concrete frame, and I can start the design and check. Okay, the value is 1006. Just keep it there. And now let's see what is the shear reinforcement right in the way. Here it is, 332. Alright, I think you remember these two numbers. And now let's get into the slideshow. And you calculate the flexure reinforcement and the shear reinforcement. This number is 1006 and this is 332 or whatever. Okay, finding out the bending moment on that figure, it is the UDL is 37.778. You can have 37.778 into W L squared by 8. L, you know, L is 6 squared by 8. So you'll get this value. Now what about the shear force? The shear force is given by WL by 2 is the shear force. Now you have XU by D. You know that's a constant from the table. Now we need to have two more constants here. One is alpha and the other one is beta. Just know its name is a concrete strength reduction factor for sustained loading. Okay, and reinforcement steel over strength factor. Okay, now the factors for depth of compressive force, just know the name. Okay, which is not compulsory, but we need to know the alpha, the value of alpha and beta. Alpha is 0.36 and the beta is 0.42. Okay, alpha is 0.36. This is alpha and this is beta 0.42. Alright, the first thing we need to find out M, and M is mu, that's the ultimate moment by width of the beam into that effective depth, the D into 0.36 into 15, that comes to be 0.1366. Just having an editing right here. This is created by someone else. That's why I'm gonna be editing this crap. Okay, now we have the where's the pen? Alright, now we need to have the limiting ultimate moment of resistance is given by this formula. All these constants, you know, this is greater than the mu, that is 170. So we don't need to provide any compression reinforcement. So XU by D could be rewritten as 244 beta m. So that comes to be 0.39. Now the depth, the Z, is equal to D, and that will give you the depth, that is it's a small d. That's the Z is a factor, I don't know his name. So by using Z, we can find out area of steel, which is equal to area of flexure reinforcement. Now coming back to shear design, we have tau V equal to VU by BD, and tau max is 2.54 M15 concrete. That's coming up right away in here. Okay, the K is 1 because K is always taken as 1. Okay. Now there's one more thing called as delta. Delta's value is also 1 because if you apply the load 37.778 here, it is 600 into 530, sorry, that 600 into D, Now if ck is 15, if you sum up that, the value comes to be 1 if the load is greater than 0. Obviously load is greater than 0 and the beam is experiencing a compression at, okay, that values comes to be 1. Now 100 AS is what you got right here. Okay, that is the area of steel into BD. That comes to be 0.596. So 0.596 comes to be right away in here, so this could be interpolated too, and you'll get the value as 0.49. Okay, now you can have ASVYS is maximum of, you got two values. It is 0.333, that is equal to 33,333 kilonewton. That's it. Is this correct? Selecting the frame and right clicking, it is 3. This is ASV. So just coming into summary, you can find, that's enough. Okay, that's all about, this is enough.